Now in this video, I will show you how to construct a simple DC circuit. Alright, so a DC circuit will have wire. So we have got wire over here. You notice that in the wire, there are tiny little balls. These are the charges. And the tiny little balls do not move and therefore no current. Right, so bear that in mind. Current exists only when the charges flow. So if I'm to form a closed circuit over here, adding in a light bulb, nothing will happen. When you notice in the light bulb there will also be tiny little charges. So as long as the charges do not move, the light bulb wouldn't light up because there's no current. So what has to be added will be this thing what we call a battery. Rightfully this should be called dry cell because it's by itself just one piece over here, so we should call it a dry cell. We will disconnect this part and bring it a bit more to the left, and we're going to add in a battery, also called in fact a dry cell. So put it together. Alright, join it up together, or not long enough. Okay, so we have got the charges moving, we have got current, and therefore the light bulb will light up. It's probably not lighting up fast enough, so we can actually do something about it. So we will disconnect over here, we're going to split it over here, and just to bring this whole thing a bit more to the right, add in another dry cell. This will make it a battery, and then we put the wire back over here. It's much brighter than before. Okay, so the more dry cells you add, the larger will be the EMF. The larger the EMF, that will mean that the current will also increase. Now next I'm going to just find out, in fact we are all going to find out what happens if a light bulb has been removed from this circuit. So here goes. So I'm going to remove this. I do not want this anymore, and I'll just connect them together. Alright, don't close your eye. Here goes. Now what's happening over here, you probably guessed it, is that the whole circuit is getting overloaded. Now overloading occurs when the current gets too large for the circuit to actually handle. The fire over here is a bit of an exaggeration, but what it's trying to tell you is that it's really the circuit is getting too hot because the current presently in the circuit is too high for the circuit to handle. So let's put out the fire. Probably we can do without this wire. Just put it aside. We'll see whether we need it in a while. So what I'll do is that I'll just put the light bulb back and everything back to normal first. Oh no, just put this. Okay, so back to normal. This is a very simple series circuit. I probably wouldn't be doing a parallel circuit for you, but you can actually try on your own. Okay. Next, what I want to show you is how do we use an ammeter. Now ammeter, as you know, it measures current, but the way to connect an ammeter is it's something that you need to know of, that it has to be in series. Alright, so we're going to split this over here, and we're going to put an ammeter. Now the ammeter that you use, or in fact the one that you should be drawing, doesn't look like this. So in fact whatever that we are seeing over here is not the schematic view of it. So when it comes to drawing, later on when I attempt a question, you will get to see in terms of schematic form how it should look like. So as I attach this, we get 1.8 ampere. Right, so an ammeter will measure the current that's flowing in this series circuit, and it registers 1.80 amperes, and is connected in series with the circuit. Now let me just remove this, just throw this ammeter aside. I'm going to use right now a voltmeter. Alright, a voltmeter usually does not look like this. What you're seeing over here, this is actually called a multimeter. A multimeter usually can be used to measure current, it can be used to measure potential differences. So what will happen is that I need to pull it over. One of the lead, I'll put it over here, and the other one I'll put it over here, and then just put a wire over. Now what you are seeing is actually the potential difference across this portion of the wire. So the potential at this point and the potential at this point, the difference between them is 0 volts. Now the reason is being for wire, it has got very low resistance. If you remember, V is equals to I times R. Okay, so what happens is that the resistance is almost 0. So the current multiplied by the resistance, that will give us a potential difference of 0 volts. So if that's the case, where can we actually register some kind of significant readings? So let's just move this to the bottom, and then the other one over here. We get a reading of 18.00 volts. This is EMF. Is not the potential difference. This is the EMF because we are measuring across the ends of a source. Okay, in this case is a battery. Then as we move the lead away and then connect it to this part of the light bulb, we're going to get a reading. The reading shows negative 18.00 volts. Now, when you get something of this sort on your voltmeter, what you got to do is to remove the lead and just interchange them. So when we interchange, we get a reading of 18.00 volts. So what you have just seen is that the EMF, the magnitude will be equal to the magnitude of the potential difference in the circuit. Okay, so that's all that I'm going to show you in this video. I encourage you to actually come to this website and try out this really fun animation yourself. Have fun.